Okay, so I got the specimen loaded. The important part is you want to make sure it's loaded in either 4 or 12, and then you want to make sure that this bevel is pointing towards the left of the screen, because that will allow us to rotate up to 70 degrees that we need without hitting the cone. So make sure that, yeah, again, the specimen is loaded in either 4 or 12 on the very edge of this, and that the bevel is facing to the left. It's almost done pumping, and then we can get started. And then make sure that we're at 20 kilovolts and 1.6 nanoamps of beam current. And a dwell time of 100 nanoseconds and resolution of 1536 by 1040. Pumping should be done soon. It's so close. Nice. Turn the beam on. Unpause that. I don't know why it's not. There we go. Someone turned the brightness way down. So now we'll find a spot to focus in on. Doesn't look like there's any astigmatism. Yeah. So looks pretty good, and we'll link this over here. We want to go to 15 millimeters. Watch this to make sure it doesn't hit the cone. Nice. We'll try relinking. Okay. So now I want to focus in a little more. Still doesn't look like there's much stigmation. Just double check. Nice. So it's pretty clean. And now we're going to tilt this first to 45 degrees, watching the whole time to make sure that it does not hit the pole. Okay, we're looking good. So now we can go to 70. Keep watching. Nice. So as you can see, I'm not sure why it's so fuzzy. There we go, that looks a little better. Going to try and find a place that's relatively flat. I'm going to do this by going out to about 250 mag, because I guess it depends on our grain size, but around 250 to 300 is a good size area. Okay, I don't know, it just looks weird. It looks different than the times we've done it before. Go back to 250 on this area. And now we put in the Ebsd detector. So you press this red button, keep your finger over the green, and watch to make sure that it's going to come in from this side right here. Just want to make sure it doesn't hit it. It shouldn't, but if we ever have to use different, like a different angle or a different plate angle or position, then that's just a really good thing to look for, to make sure that we don't have to spend $800 on a new phosphorus lens. So it comes in, it gets closer than you'd like, closer than is comfortable, but it'll stop before it hits it. And now we go ahead and pause this. Now we're on. Come over here, open team. This is on page 1. Now we're going back to page 2. Okay, it's still opening. Usually, I don't remember it taking this long. Okay, here we go. This looks different. Okay, there we go. So we log in here, and then we will use this as our project, but right now I'm just gonna do training. Open it up, and then come over here to the right side, click the triangle for advanced properties, click Ebsd camera, and then we want to get that frames per second to, I think 123.4 is the max, at least for this one. So make sure double clock is checked. Desired binning, we want 8 by 8. Then image processing to none. And now we adjust exposure for, we'll have to figure it out for our specific samples, but for this we want to go to 8.1, and then we increase the gain until we see this, and we want this to be hitting 1 every once in a while, but not stuck at 1. So yeah, like that's about good. And that's what we want it to look like for our, from what I understand, that's what we want this to look like for most of our samples. So then go to image processing. We want the frames to be double our frames per second. So we'll do about like 250. OS. And then image processing mode on this, we go standard, and that's what it should look like. And then we go to image area, and we do not want tilt correction for this. And then this will cause an image to be taken. That looks so weird. Okay, coming back, there's a problem with the software, so it should be up now. I got back to where we were at and then just clicked capture background to capture this, and then come back down. That's something that's not in the instructions as well. So click capture background. I guess it doesn't really matter because when you click tilt correction, it'll take another image anyways. So then once this loads, so that's what it should look like. You should see what's on here. This wasn't saying external last time, and so and the image wasn't paused, so it wasn't taking the picture like it, or the image like it should. So if that ever happens, see if it says external right here on this screen, and make sure it's paused. If not, then there's a problem, and go talk to Paul. So we can close this now. We go to project content, and then go to profile, and then we type in what we want here. So here we're working with nickel. If you click, and then they all show up here. If you click phase, it sorts them in alphabetical order. So we want nickel. If you want to remove one, you just click over here, remove phase. And then if you come back here, click on the phase you want, click this button, and it moves that over. don't click this because it'll move all of these phases over to here, and that's not what we want. So once we have that, press OK, and then we come up to survey and click image area. Make sure that this is red. If it's still green, it says take beam, then you want to click that. So then click here. Just click anywhere. Try to click close to the middle, but you see the confidence interval is really low. We want it to be at least 0.1, but ideally 0.5 or higher. So if you click this button, it auto tunes it. That's not super high. See if a different area works better. See now it's 0.34. Click it, and now we're at 0.97, so that's really good. The fit is at 0.4. We want it less than, it's at 0.4 degrees, which is good. We want it to be ideally less than 2 degrees, at least less than 2 degrees, ideally less than 1 degree. So once you have that, then you can come over to here, to settings, and then close this stuff, go into Huff. You want to make sure we have a bin pattern size of 96, data step size of 0.5. The row fraction should be in between 85 to 90 degrees, or 90%, which it is. And then for a cubic structure, we want 7 max P count. For a hexagonal structure, we want 9, and then the less symmetric it gets, the higher the max peak count should be. And I believe that's all of the settings to look for. And this, we'll have to come up with them depending on what sample we use. So with our aluminum ALSI 10 mg samples, we'll talk with Paul and try to come up with more presets for that. So then once we've done that, come up to mapping. And then we'll adjust this display box. I'm gonna open up these advanced settings. Let's see. In Ebsd mapping, want to set grid type to square, and then you have to control it through this corner, and then you can drag it around. With this, you can do, we'll try to get them even, so we'll say like 600 by 600, and then drag this to the middle of the screen. And then for resolution, we want to go to custom. There we go. And now we can change the step size. To figure out how long the scan's going to take, we take this number of points right here. So we'll do 3721 and divide it by our frames per second, which is 123, and then we can divide that by 60, so that'll only take half a minute. If we increase the step size, say to 15, so it increased it, or it decreased it. If we take our step size to 6, then it increases it. So if we're now at 10,302 divided by 123, okay, and then divided by 60, less than a minute and a half, so it'll be pretty good resolution, and won't take too long. It really depends on what we're trying to look at. If we just want grain sizes, then the step size will, because we don't want our step size to be less than our grain size. So if our grain size was, say, like 100 nanometers, then this would be way too big and we want to get anything. But because the grains are pretty big in here, we'll be able to capture a lot of information about the grains just with this 6 micrometer step size. So then let me see, just click collect map. Let me double check. I think, yeah. So we click map. And we can see the different colors. Different colors represent different grains. Here we can look at, we can control what we see. So right now we're just looking at the IPF. We can go to image quality. For image quality, red is good, which is weird. But for confidence interval, green is good. And you can see kind of that the confidence interval and the image quality are worse where there's scratches and bumps. So go back to here. Yeah, if there's not enough information or we don't like what we see, we can always come back and change our parameters over here, either change the image area or change the step size to try and get more information out of it. Once this is done, then we will save it. Okay. And we click finish. We can click report. And it has a report, and we can save it to the SEM or to a Dr. Baird's drive. Okay, I forgot to click the pause button instead of the end button. But now the first thing we do, so once we get the report and save it, just close out of the Teams. And the very first thing you do, unpause this and click the out button to withdraw the Ebsd, and don't do any tilting or anything until it completely stops moving, because right here, even though it looks like it's all the way out of the way, if we tilt it before it's done removing, then we're gonna hit it because there's a really small area of space. So then we will move it down another 10 millimeters, so we'll go to 25. And then once we're there, we can untilt, go back to 0, and then vent and remove the sample, and that's it.